Alright, welcome everyone to the next lesson in this series, and in this video we will look at DNS in a Kubernetes cluster. Now DNS is a very important component in a cluster, and that's because when you deploy pods or workloads in the cluster, you need a mechanism whereby they can seamlessly discover other services and communicate with those services. Now in the previous lesson we looked at cluster IP services, and we also looked at how the pod relies on name lookups to discover the IP of those cluster IP services. So in this video, we will do a bit of a deep dive into how DNS is configured for pods in the cluster, as well as how the DNS service is deployed in the cluster. Okay, so let's get started. Okay, so let's first cover some of these points here. Now, DNS is used for service discovery and name resolution for services inside as well as outside the cluster, and we will look at how it does so. Now, one of the main reasons as to why DNS is crucial in Kubernetes is because the IP addresses of pods as well as services are ephemeral. These IPs will change as those pods and services restart. So you need a reliable mechanism whereby pods can discover these services, unlike other environments where IP addresses tend to be long-lived. Okay. Now it is kubelet that configures the resolve.conf file in a pod so that the pod leverages the cluster's DNS service. And we looked at how kubelet does this in the pod networking lesson, but we will do a bit of a deep dive in this lesson as well. Now, as part of the configuration that kubelet performs, it also creates certain cluster search domains based on the namespace in which a pod or workload is scheduled. And we will look at how these cluster search domains can impact the way in which DNS lookups are done in a pod. Okay. Now, CoDNS, which is typically the pod that provides the DNS service in the cluster, answers queries for services inside as well as outside the cluster. So if there are unknown domains to which lookups are sent, CoDNS will forward those name lookups to upstream resolvers. Okay. Now, CoDNS, which is the pod that provides or backs the DNS service in Kubernetes typically, will answer queries for services and pods as well as forward unknown domains to upstream DNS resolvers, and we will look at that in this lesson. So basically it supports both in-cluster lookups as well as external DNS resolutions for pods in the cluster. All right. So with that covered, let's next go into the lab. Okay, so in my environment, I have already deployed the lab. If you've cloned this repo, this particular lab can be found in the K8s-DNS folder. And the instructions to deploy these labs are provided as well. And we covered this in a previous video as well. There is a deploy script in this folder, and I have gone ahead and run that deploy script, and my lab is currently provisioned. Okay, so let's first quickly go through the status of this container lab topology. We have a 3-node Kubernetes cluster, very similar to some of the previous lessons. And I'll next export the kubeconfig file, the deploy script in this folder. Once it has deployed the kind cluster, will create a kubeconfig file. So I'm exporting that as an environment variable. And once done, I'm going to look at the pods in the default namespace here. So I have a few test pods, some multi-tool pods, as well as Nginx deployments. We will use some of these pods to test and verify how DNS is configured in this particular cluster of mine. Okay. So some quick commands to verify the cluster setup. Like I mentioned, we've covered how to deploy this lab in a previous lesson. I will have a link to that somewhere in this lesson as well. Okay. All right. So with that, let's next verify the DNS service in this cluster. Now, in every Kubernetes cluster, you're going to find a DNS service. This is typically named kube-DNS. And this service is going to have a cluster IP. So the DNS service is also a cluster IP service. Okay. Now the IP address is typically .10. So in this particular kind cluster, and if I go to the kind configuration here, which is this one, I've specified the service subnet as 1096.0.0/16, and typically the DNS cluster IP is .10. All right. So in this case, my DNS service cluster IP is 1096.0.10, and we can see that this service is available on UDP 53, TCP 53, as well as TCP 9153. These tend to be typically the DNS ports. Okay, so we have this service, and next, if I look at the endpoints backing this service, I see there are two endpoint IPs. So the first one is 192.168.2066, and then 192.168.2067. So these two endpoints are what backs this particular service, right? So when a pod in the cluster sends a DNS lookup, it lands on one of these endpoints. Now, these endpoints, I'm going to go into a diagram over here. Let me expand my window. Okay, so in this diagram, I have two pods, and these two pods, they correspond with the two pods that we see backing the Kube DNS service. And in this case, these pods are co-DNS pods, and co-DNS is a DNS server that is widely used in Kubernetes. So we use the co-DNS image for the DNS pods in Kubernetes. So 10.96.0.10, this is the cluster IP that we saw over here. Now pods, they have their DNS resolvers configured by Kubelet during startup, and Kubelet is aware of this cluster IP. So it configures the name server to point to this particular cluster IP. And pods would then send DNS queries to the name server configured in their DNS resolver. Okay, so this is what the end-to-end flow looks like for DNS lookups. All right, so with that, let's go back to the lab guide over here. So next, what we're going to do is we're going to verify the two core DNS pods. So if I do a kubectl get pods with this specific label, app equals kubedns, I'll be able to see the two core DNS pods here and their corresponding IP addresses. And these pods are deployed in the kube-system namespace. Okay. All right. Now, next, what I'm going to do is I'm going to retrieve the config map for the core DNS pods. Now, there are certain parameters that can be tuned. We're not going to look at these parameters in this lesson. However, we'll probably have an advanced DNS lesson in which we will explore these parameters in detail. However, in this lesson, what I want to highlight is this particular configuration over here, which is forward./etc resolve.conf. What this essentially means is that when these pods, when they receive a DNS lookup for a domain that is not within the cluster, it will forward those lookups to the host's DNS resolver. Right. The kubedns pods are deployed in a particular node in the Kubernetes cluster, and that node has a resolver as well, right? So when CoreDNS receives a name lookup for a domain that is not within the cluster, it's going to forward that DNS query to the resolver configured in the host, and that is determined by this particular configuration. Now, you can forward unknown DNS lookups to other name servers as well. Now, this one is customizable, and you can be a bit more nuanced in terms of how you set up your forwarding configuration, but that is outside the scope of this particular lesson. Okay, so this is what the end-to-end flow in this case looks like. If a pod in the cluster does a DNS query to a domain that is not within the cluster, or for a domain to which kubedns is not authoritative, kubedns is going to forward that lookup to the host's DNS resolver, and that is going to have a name server configured for external DNS lookups. So the query essentially goes to that name server configured in the host's DNS resolver for external lookups. Okay. Okay. So next, let's quickly verify that. What I'm going to do next is I'm going to exec into one of the nodes in the cluster, K8s DNS worker node in this case. And if you do a cat/etc/resolve.conf, we see that this 172.18.0.1 is configured as the name server in the host resolver. Now, remember that we're using container labs, which means the node in this case, or the host, is a container as well, right? And 172.18.0.1 is the IP of the Docker Bridge gateway. And essentially, when a DNS query is sent to this IP, it gets forwarded to the underlying host's DNS resolver, right? Which then forwards it to the name server configured in that resolver. Now, if I exit from this particular Kubernetes node, which is a Docker container, this is my underlying host, right? So this node is essentially a container deployed in this particular host. And if I do a cat slash etc slash resolve dot conf, we're going to see that the name server is 127.127.0.0.53. Now, what this means is that this particular server is relying on systemd resolved, which is what provides DNS in most modern Linux operating systems. And if you want to look at which name server that service is pointing to, I'm just going to run a command here, and you can see that the current DNS servers are 10.0.0.2, which is probably a DNS service, in this particular VPC of mine. We kind of went into a bit more detail there, but in your clusters, probably when you're running Kubernetes in production environment, your clusters are going to be actual VMs or EC2 instances or bare metal servers, right? So just bear in mind that in those cases, kubedns is going to forward traffic to unknown domains. It's going to forward it to the host resolver, and the host resolver will ultimately send it to the name server configured in that resolver. Okay. All right, so let me clear this. Let's go through the rest of the steps in the lab. So what we're going to do next is we're going to exec into one of these multi-tool pods in my lab. Now just bear in mind that the name of the multi-tool pod in your lab is going to be different to mine. And let's look at the resolver configuration in this multi-tool pod. Now, as noted before, the name server is 10.96.0.10. However, we also have certain search suffixes configured in this file. Now, this is a very important point. So there is another configuration here called options n.5, right? So for example, let's say if I do a DNS lookup, let me do a NS lookup to Nginx service, which is a service in this particular cluster. And you see that although I just provided a short name, when I got the response to nginx service.default.spc.cluster.local, right? So every service has a FQD and a fully qualified domain name. And even though I provided a short name, the DNS resolver appends these suffixes and tries to resolve the host name using a fully qualified domain name. Now, the ndots configuration plays an important role there. When I provided the host name here, I didn't provide any dots, which means it was less than 5 dots. So then the resolver will append these search suffixes. So when you have or provide a host name that has less than 5 dots, the resolver is going to attempt to resolve that query by adding the search suffixes to the end of that query. Now, there are some pros and cons to this. The pro is that I can do a DNS lookup using a short name, just like what I did here. But the cons are sometimes it could add to DNS latency because for every query, the resolver is gonna append this particular suffix, and that could also result in an increased number of DNS queries as well. Now, there are ways in which you could mitigate some of those issues, and I'll cover that in a future lesson, okay? But for this one, just bear in mind that as kubelet configures the DNS resolver, the name server is configured, as well as, the search suffixes are configured as well, and the n.dot configuration is configured as well. And then all of this are tunable, okay? Alrighty, so that was so we did a NS lookup in this case. You could do a dig nginx service as well. Now, when you do a dig without providing any flags, if you look at this response actually failed, right? And the reason for that is dig by default is gonna do a lookup to the absolute name. So if I look at nginx dot, and the dot is the root of that DNS query, and this is essentially a fully qualified domain name if you have a trailing dot this way. And we don't have such a host anywhere in the network. If you look at the service, the fully qualified domain name is nginx.default.svc.cluster.local. So when you do a query to nginx dot as a fully qualified domain name, that query fails. Now, if you're using dig, and if you want dig to append the search suffixes. You can do dig plus search and provide the name of the service, the short name of the service, in which case dig appends the suffixes. And as you can see, we in this case received a response for nginx-service.default.svc.cluster.local, right? So that's something important to bear in mind. So let me clear this. And next, what we'll do is I'm going to go into a multi-tool pod that I have in the foo namespace. If I do a kubectl get pods -n foo, we have a multi-tool daemon set here as well. So let me exec into one of these pods and let me do a cat to the resolve.conf file. And there is a very important distinction here. So if I look at the search suffixes, in the previous one, it said default.svc.cluster.local, and that's because that particular multi-tool pod was deployed in the default namespace. And in this one, it says foo.svc.cluster.local because this pod is deployed in the foo namespace. Now, what that means is if I do a ns lookup for the nginx service in this pod, I'm going to get a server fail. Why is that? And that's because this nginx service is deployed in the default namespace, and none of the search suffixes that get appended correspond to the fully qualified domain name of that nginx service, given that this particular pod is in a different namespace. Now, this is something very important to bear in mind. So one way I could address this problem is, instead of saying dig.search nginx, so for example, if I just copy this, I'm going to get a server fail. So instead of just saying dig.search nginx.service, I can append it with .default, and then I get a response for nginx.default svc.cluster.local. I get a successful response. And that's because essentially it's going to try appending all of these search suffixes. So if it appends foo.svc cluster.local after nginx service.default, that's going to fail. But then it's going to append svc.cluster.local, which then, along with this, corresponds to the FQDN of that particular nginx service. And that's how this particular lookup is successful. All right. So that's it for this lesson. Hopefully you understand how DNS is deployed in the cluster, how the service is configured, how the resolvers are configured, and the backing pods, as well as the config map that is attached to the backing pod that instructs it to forward queries to unknown domains to the name server configured in the host resolver, right? And we also looked at how the search suffixes work and how DNS resolution varies depending on which namespace a service is deployed in. Okay? All right, so that's it for this lesson. I will see you in the next one. Thanks for watching. Bye for now.